Before we dive into this story, let me ask you something. Have you ever wondered how far human curiosity can really go? How we went from dreaming about other planets to actually driving machines across them? If questions like that pull you in, then you are in the right place. Welcome to Orbit Mytha Channel, where we explore the untold stories, mysteries, and hidden truths of space science and the universe beyond Earth. And today, we are traveling back to the very beginning of Mars exploration to uncover a story most people have never heard before you settle into this video. Let me ask you something. Have you ever stopped to think about how strange it is that humans can drive machines on a planet millions of miles away? And if that already sounds impressive, here's a twist most people never hear. The very first Mars rover was not built by NASA, and it did not come from the modern age of robotics. It was created more than 50 years ago by the Soviet Union. And once you hear how that story begins, you may never look at Mars exploration the same way again, right? Now you might be assuming that early Mars exploration looked nothing like what we have today. No high-resolution cameras, no advanced computers, no autonomous navigation, and you would be right, but what might surprise you is how bold engineers were even back then in 1971. The Soviet Union launched a mission called Mars 3, and with it, they attempted something no one had ever successfully done before: land gently on the surface of Mars. And not just land, but attempt to explore it. Mars 3 became the first human-made object to achieve a soft landing on the red planet, and that alone was a massive achievement for the time. But hidden inside this mission was something even more ambitious: a tiny experimental rover named Prop M. If you are picturing something like Curiosity or Perseverance, you can clear that image from your mind. Prop M was nothing like the rovers we know today. It was a small metal box, barely larger than a book. Weighing just a few kilograms, it had no wheels, no cameras for navigation, and no ability to roam freely across the planet. And this is where a natural question forms. Why would anyone send a rover without wheels to Mars? What the Martian surface would really be like. Prop M used a flat, ski-like plates, mounted on arms, allowing it to slowly step across the ground. And its only job was to measure the density of Martian soil using a small probe that extended from its body. Unfortunately, this story took a tragic turn just seconds after landing. Mars 3 stopped transmitting data after only 14 seconds. The signal went silent forever, and the only thing received on Earth was a scrambled black and white image. Prop M was never deployed, and the mission appeared to be a failure. But here's something worth pausing on. If you are thinking that this mission was pointless, you would be wrong. That tiny box represented the very first attempt to move across another planet, and it quietly laid the foundation for everything that came after. For many years following Mars 3, the red planet went silent again, and you might be wondering why there was such a long gap between missions. The truth is simple. Landing on Mars is hard. Surviving on Mars is harder. And understanding Mars requires patience. NASA learned this lesson during the Viking missions of the mid-1970s. Viking 1 and Viking 2 were launched during a rare alignment between Earth and Mars. And in 1976, they delivered the first detailed images of the Martian surface. For the first time, humans saw Mars not as a distant red dot, but as a real place, a rocky, cold, empty world shaped by ancient forces designed to analyze soil chemistry, atmospheric conditions, and possible signs of life. And this is where another question naturally arises. If Viking provided so much information, why did Mars exploration slow down again? The answer lies in scale. Viking landers could only study the ground directly beneath them, to tiny points on a planet nearly the size of Earth, finding evidence of ancient life. This way was like searching for a single grain of sand in a desert. NASA realized that real progress would require mobility, the ability to move, follow clues, and explore different regions. And that meant building something entirely new. That vision finally became reality in 1996. With the Mars Pathfinder mission. Pathfinder was another lander packed with scientific instruments, but this time it carried something revolutionary. A small rover named Sojourner. When Sojourner rolled onto the Martian surface in 1997, it instantly captured the attention of the world, and if you were alive at the time, you probably remember it. Seeing a robot drive across another planet felt unreal, like science fiction suddenly becoming real life. But Sojourner was not just a symbol, it was an experiment. Engineers did not know if a rover could survive Mars: sharp rocks, uneven terrain, extreme temperatures, and communication delays. And this raises an important point. If you are wondering how NASA was able to drive a rover millions of miles away, the answer is they could not do it in real-time signals. Take minutes to travel between Earth and Mars, so Sojourner had most of the science was still done by the lander, but it did have a tool that could analyze the chemical composition of rocks. It could drive up to an object, press against it, and determine what it was made of. It also had a basic form of autonomous navigation using cameras and laser sensors. To avoid obstacle space, NASA could only communicate with the rover once per day. Engineers would set a destination, and then wait until the next session to see where Sojourner ended up over 3 months. It traveled about 100 meters, and while that may not sound impressive, it exceeded expectations, and proved that mobile exploration on Mars was possible. That single success changed everything, and here is where the story truly accelerates. If one small rover could do this much, imagine what larger, more capable machines could accomplish. This idea led directly to the Mars exploration rovers. Spirit and Opportunity launched in 2003 during another rare transfer window. This time, the lander and rover were a single integrated system. Once they landed, they unfolded their solar panels, deployed their instruments, and drove away on their own. Compared to Sojourner, these rovers were massive, closer to the size of golf carts. They still used the rocker boogie suspension, but scaled up to carry far more equipment. Each rover had a tall mast with multiple cameras, capable of creating 3-dimensional panoramic images. For the first time, scientists could see Mars in depth and detail. Each rover also carried a robotic arm with a spectrometer, allowing them to analyze rocks and soil up close. And this is where many viewers naturally assume that these rovers were designed for short missions. But reality had other plans. Spirit operated for 6 years, traveling nearly 5 miles across Mars. But Opportunity went far beyond expectations, lasting more than 14 years. And traveling over 28 miles before finally falling silent during a massive dust storm that covered its solar panels. Opportunity became more than a machine. It became a symbol of human curiosity, resilience, and exploration. And when it finally stopped communicating, people around the world felt a real sense of loss. At this point, NASA had learned a tremendous amount about Mars terrain navigation and long-term survival, and that knowledge led to the next evolutionary leap. Curiosity launched in 2011 and landed in 2012. Curiosity was unlike anything before it in size, power, and ambition. If you are picturing another golf cart, you need to think bigger. Curiosity is roughly the size of a small SUV. This brings up an obvious question. Why make it so big? The answer lies in science. Curiosity carried an entire mobile laboratory, capable of analyzing organic compounds, studying radiation levels, and drilling into rock samples. And unlike previous rovers, Curiosity did not rely on solar panels. Instead, it was powered by a radioisotope thermoelectric generator, a system that converts heat from radioactive decay into electricity, allowing the rover to operate day and night, regardless of dust storms, with enough fuel to last over a decade. Curiosity is still active today, continuing to explore Mars and sending back valuable data, but Curiosity was not alone for long. In 2021, it was joined by Perseverance, a rover built on a similar platform but equipped with even more advanced instruments, including something never before sent to Mars: microphones. For the first time in history, we could hear Mars, the sound of wind moving across the surface, the crunch of metal wheels over rock, the hum of motors, and the squeak of suspension. Named Ingenuity tucked beneath its body. And this is where many people naturally ask the same question: how can a helicopter fly on Mars? The atmosphere there is incredibly thin, less than 1%. The density of Earth flying there is like trying to fly at nearly 90,000 feet on Earth, higher than any helicopter has ever flown. To make this possible, Ingenuity used 2 large counter-rotating propellers, spinning at extremely high speeds. Its blades were made from ultra-lightweight materials and carefully shaped for maximum lift. NASA tested the helicopter in vacuum chambers, simulating Martian conditions, including low air pressure, reduced gravity, and wind. Even then, many engineers doubted it would work. The original plan allowed for just 5 short test flights. Instead, ingenuity exceeded every expectation over 3 years. It completed 72 flights, spending more than 2 hours in the Martian, sky scouting terrain, capturing images, and proving that powered flight on another planet was possible. This success is already reshaping the future of exploration. NASA is now developing larger helicopters capable of flying kilometers in a single mission. Carrying scientific instruments far beyond the reach of wheeled rovers, flying machines may soon retrieve samples left behind by Perseverance and Future. Missions could deploy fleets of aerial explorers, not just on Mars, but across the solar system. NASA is even preparing a drone mission called Dragonfly to explore Saturn's moon Titan, a world with a thick atmosphere and rivers of liquid methane. A place where flight may be easier than driving when you step back and look at this entire journey from a tiny ski-walking box in 1971. 2 helicopters flying on another planet. One thing becomes clear. Progress in space exploration does not come from giant leaps alone. It comes from countless small risks, lessons learned, and failures that quietly push us forward. Mars has become our proving ground, a place where we learn how to explore, survive, and adapt beyond Earth. And if we can master exploration on Mars by land and by air, then the possibilities for the rest of the solar system are almost limitless. This story is not the end, it is only the beginning.